All right, so our last packet, woohoo, Unit 9, so vector, parametric, polar, that sort of thing. So particle moves in the xy plane such that its position is given by this in terms of x, in terms of y. What is the slope of the tangent? So when they say what is the slope of the tangent, they're asking for the derivative. And so that's going to be y prime divided by x prime, or dy dx. So y prime is going to be e to the 2t minus 7 multiplied by the derivative of the exponent, which is 2. On the bottom, we have the derivative of x, which is 6t minus 19. And then they want the particular slope when the particle is at t equals 4. So we're going to take the dy dx, we're going to evaluate it for t equals 4. So that is 2e to the 2 times 2 minus 7 over 6 times 4 minus 19. So on the bottom I can see that that's going to be 5. 24 minus 19 is 5. And then here I've got 2e to the 8 minus 7 is the first power. So 2e over 5 is d. Number 2. The path of the particle, we want an integral expression that represents the length of the path. So the length of the path is the square root of x prime squared plus y prime squared. And then it's on that interval, so from 2 to 6. All of the answers have from 2 to 6, so they weren't really testing you on that. So x prime is 1 over t. Y prime is 10t. So we've got 1 over t squared plus 10t squared. And so for the first one, this gives us 1 over t squared plus 100t squared. And so that is answer A. All right, number 3, the position vector. For what value of y does the path of the particle have a horizontal tangent? So to find the tangents, we find the slope, right, dy dx. For it to have a horizontal tangent, we want the top to be 0 and the bottom to be a number. So I went ahead and I took just y prime. And so I got 3t squared minus 12. And I went ahead and set that equal to 0 so I could solve it. So 3 times t squared minus 4, 3 times t plus 2 times t minus 2. And so my two values for t were t equals negative 2 and t equals positive 2. Negative 2 is not going to work because it is not on the interval from 0 to 2 pi. So this is the t value that we're going to use. And so the value of y is the value we get when we plug that 2 back in. Now typically you would, depending on the problem, depending on the multiple choice answers they give you, you would probably also want to check to make sure that there's not a vertical tangent at that same point. And the reason I don't have to worry about checking it is there's not an answer choice that says like none, or it doesn't. So because there's only one answer here, I don't really have to check, I just know that's the answer. But if you guys recall, if it was 0 divided by 0, then there would be a cusp there. It wouldn't be a horizontal tangent or a vertical tangent. So sometimes we do have to watch out for that. But in this particular problem, I know that there's for sure an answer, and I only got one possible way to get to the answer. So now I'm going to do y prime evaluated using 2, and that gives me 3 times 2 squared. Wait, what value of y? Oh, this is not y prime. Pretend I didn't do that. So the actual function evaluated at 2. 2 to the 3rd minus 12 times 2. That is 8 minus 24. And so the path of the particle has a horizontal tangent at y equals negative 16. So the reason we use the original function, not the derivative, is because it wasn't asking us about the rate of change at 2, it was asking us about the position at 2. And so that's why I needed to use the original. All right, number 4, we have a plane curve with parametric equations. We got 2 of them. We want to find an expression for the rate of change of the slope. I got this one wrong because I read it too fast. The slope is the first derivative. The rate of change of the slope is the second derivative. So we do need to find dy dx. We do that by doing y prime divided by x prime. So y prime is 4t to the third plus 6t divided by 2t. And what I went ahead and did is I simplified that. So on the top you can factor out a 2 and a t as a GCF, and your leftovers are 2t squared plus 3 divided by 2t. And this is a great distractor answer because that's one of the answer choices, but that's not it because we're doing the rate of change of the slope. So the second derivative is the derivative of this divided by x prime. So the derivative of dy dx is 4t, and then x prime is 2t, and the t's cancel out, and 4 divided by 2 is 2. So we got to watch out for that wording. All right, a particle moves, and we want to see which direction it's moving. So they break it up into left, right, up, and down. So that means that we just need to see at the x value when t is 1, when it's moving, so we want to find x prime. And then we want to evaluate it at 1. So this would be 2t minus 4. When we evaluate it at 1, we get 2 minus 4, which is negative 2. So that means that this is moving to the left. The particle is moving to the left. So not this one, not this one. We can determine it. And then we want to find y prime, which is 1 over t. And y prime of 1 is going to be 1 divided by 1, which is 1. So that means it's moving up. So left and up. I got this answer wrong because I chose C. I wrote off all this information and then I chose C. So be careful to check to make sure you write the correct answer. All right, we have a velocity vector. They want to find the position vector. So if they gave you the velocity vector, you just need to integrate each piece. So I'm integrating the third root of t, which I'm going to rewrite as t to the 1/3 dt. And then we're integrating 6e to the 2t minus 2, so I'm going to put the 6 in the front. E to the 2t minus 2 dt. So 1/3 plus 1 is 4/3, so we're dividing it by 4/3. So that gives me 3/4 t plus c. For this one, I'm going to have to do u substitution. I'm going to write it off to the side. So my u is 2t minus 2. The du is 2 dt. And so we have to divide by that 2 since it's not sitting in the front there. So 6 divided by 2 is 3. So we've got 3 times the integral of e to the u du. So the integral of e to the u is just e to the u. So that gives us 3 e to the u, and I can go ahead and substitute my u back in, plus d. So there is our velocity vector for the position of the particle. Now they tell us the position of the particle at t equals 1 is 0, 5. So for this one, when I plug in 1, I'm going to get 0. I know what I missed is that exponent. 1/3 plus 1 is 4/3. Whew. Sorry about that. Did you notice that? I missed that? All right. If you plug in 1, you get 0. So 3/4 times 1 to the 4/3 plus c equals 0. For this one, when I plug in 1, I should get 5. So 3e to the 2 times 1 minus 2 plus d equals 5. And we just have to solve those. So 3/4, 1 to the 4/3 is still just 1. So we've got 3/4 plus c equals 0. So c equals negative 3/4. So this one would be 3/4 t to the 4/3 minus 3/4. And then the other one, 2 minus 2 as an exponent is going to give us an exponent of 0. and e to the 0 is 1. So 3 plus d equals 5. We can subtract the 3 over d equals 2. So 3e to the 2t minus 2 plus 2. So answer is E. All right, particle is moving as a position vector. We want the acceleration vector, so that means that we need to have the second derivative. So this is x of t right here. V of t is going to be e to the 2t times 2. I'm going to think of this as t to the positive 1/2. So that's 1/2 t to the negative 1/2. So the acceleration vector is going to be 2e to the 2t times 2. Negative 1/2 times 1/2 is negative 1/4 t to the negative 3/2. And then we just have to clean our answer up a bit. So that's 4e to the 2t. And this, they wrote all these answers as fractions, so we're going to do that too. So 4 is on the bottom. And then we've got a square root. Oh, actually, it looks like they just left them to the 3/2. So the answer here is C. All right, for this next one, you can use a calculator. So here we have r equals 3 divided by 2 minus cos theta, and x is r times cos theta. So x is going to be 3 over 2 minus cos theta times cos, which is 3 cos theta divided by 2 minus cos theta. Y is r times sine. And so that means that y is 3 sine theta over 2 minus cos theta. The slope is dy dx. So the derivative of y is, this is a quotient rule. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. All right, so that's your y prime. Your x prime is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And you'll notice these two denominators, they're the same, they actually cancel. And so what I did, since this is kind of a lot to plug in, we're going to evaluate this at pi halves, is I went ahead and I typed in pi halves and I stored it as x in my calculator. I did that because it just makes things a little bit easier to plug in. So now I can type this in as a fraction. So I've got 2 minus cos x times 3 cos x minus 3 sine x times sine x divided by 2 minus cos x times negative 3 sine x minus 3 cos x times sine x, and I get 1/2. So it's B. All right, number 9 says the position vector, we want to know what the distance traveled is. So the distance traveled is like arc length. And so the formula for this is, we've done it already. Did they phrase it the same way? The path of the particle, we did it on number 2. Yeah, the length of the path, distance traveled, same thing. So here our distance is traveling from 0 to pi, and we have the square root of x prime squared, so 2t squared, plus y prime squared, so cos t squared. And then I went ahead and just plugged that into my calculator, and I got 10.354. That was not too bad. The area inside the polar curve, the really nice thing about this one is that there's no loop to worry about. You don't have to have an inner loop or an outer loop or worry about things repeating. So with this one, you just have to remember the area formula, which is 1/2 times r squared d theta. So I've got the 1/2 in the front. You also have to know that the interval of this is 0 to 2 pi. And then we just have to do r. Make sure we plug this in correctly. You should not be using me as your human calculator. You should be typing this yourself to make sure you're getting your parentheses in the right place to get the right answer. But the answer ends up being D. All right, 11. Okay, particle moves so that its acceleration vector is this, and they want the velocity vector when t is 1, so we have to go ahead and do that first. So I integrated 6 times t squared dt, and then 21 over t dt. So plus 1 divided by 3. So 6 divided by 3 is 2, so this is 2t to the third plus c. This is 20 ln of t plus d. There's our velocity vector. We need to know what the velocity vector is if the t is 1. So I have 2 times 1 to the third plus c equals 5. And I've got 20 ln to the 1 plus d equals 0. So this is 2. 2 plus c equals 5. So c equals 3. So that's 2t to the third plus 3. And then over here, ln 1 is just 0. That whole thing zeroes out, so the d is 0. So that's 20 ln t. And then we want to know how fast the particle is moving when t equals 3. So the speed is the velocity evaluated at 3. And it's the absolute value of that. We always know that the absolute value of the velocity is the speed. But in this case, for this, since it's a vector, we know that it's actually the magnitude. So we're going to plug 3 in here. When you plug 3 in there, you get 57. So we're going to do 57 squared. And then when you plug 3 in here, you get 21.972. So plus 21.972. Of course, I'm not using a rounded number here. You can store it, or you can use the actual decimal. So 57 squared plus 21.92 squared underneath the square root sign, and you get 61.088. All right, number 12. So here we want, again, the distance traveled by the particle. I don't know if you guys have noticed, but as I've been doing these problems, they're all very similar. They're not that hard. They're all like, I guess if you know the formulas, they're okay. So it says on the interval from 1 to 5, so we know we're doing that. They gave you x prime and y prime. You don't have to find it yourself. I guess that could mess people up. So when I square this first one, I get e to the 4t. When I square the second one, the square and the square root cancel out. So the correct answer here is D. All right, number 13. The area enclosed by the polar curve. So here we have a lemniscate, or lemniscate, as we joked in class. So if you guys remember, we did one of these in class and we had issues. We knew that it took, that 2 pi was what was needed to create the curve, but because the way the curve is graphed, it made it so it had an area of 0. So what we did is we found just the area of this part. We did from 0 to pi fourths, and then we were able to take that and then just multiply that by 4. So what we're going to go ahead and do is we're going to treat that the same way this time. So we've got 1/2, and we're going to go 0 to pi fourths of, and it's r squared, but r is already squared, so that's 10 cos of 2 theta d theta. This is a calculator inactive question, so I've got to go ahead and pull that 10 out of there. So that gives us a 5 in the front. Let's take that 10 out. And now we're making this a u substitution problem. So u is 2 theta, du is 2 d theta. So that means that we've got to pull the 2 in the front. So 5/2 times the integral of sine u du. Oh, I already did that. Cos u, sorry. The integral of cos is sine. So it's 5/2 times sine of 2 theta. We're evaluating this from 0 to pi fourths. So this is going to be 5/2 sine, 2 times pi fourths is pi halves, minus 5/2 sine, 2 times 0 is still 0. So that's nothing, because sine of 0 is still 0. Sine of pi halves is 1, so that gives us 5/2. So this right here is 5/2. We've got 4 of those, so times 4. 20 divided by 2 is 10, so the answer is A. All right, number 14. So here, a particle moves in the xy plane so that its velocity vector for time, which of the following statements is true? Now, I looked here and I saw that it was all about the speed of the particle and acceleration and stuff, and if you recall, you can find if something is speeding up or slowing down based on the signs of the velocity vector and the signs, well, just signs of velocity and acceleration. In this case, we've got vectors. So what I went ahead and did is I knew that this was the velocity vector, so I went ahead and took the derivative of that to find the acceleration vector. So the acceleration vector is going to be 1/2 times 100 minus 10t to the negative 1/2 times negative 10. So that was me doing the chain rule. The derivative of 2t is just 2. So this is negative 10 times 2 is negative 5. And square root of 100 minus 10t. I've been going back and forth since they don't do these little sideways ones. Anyway. All right, so there's our acceleration vector. So there's a couple answers we can kind of get rid of if we just evaluate these at 1. So my velocity vector evaluated at 1. 10 times 1, that's 10. So 100 minus 10 is the square root of 90. And then 2 times 1 is 2. Now, just because those are the numbers does not mean that the speed of the particles is root 90 plus 2. That's not how that works. And so we're going to take that out of there. If you guys remember, to find the speed from the velocity, we do the magnitude. And that is not the magnitude. The acceleration vector, okay, so we need to go ahead and find that. So if I plug in 1, I'm going to have negative 5 over the square root of 90, and then 2. It's like that's definitely not E. So what I noticed here is that these are both positives. That didn't tell me a whole lot. So I wasn't really sure if there was enough information for us to tell from here. So I went ahead and I just went back and I said, all right, I know that the speed is the magnitude of the velocity vector. So if you do the magnitude of the velocity vector, you're going to have the square root of 100 minus 10t squared plus 2t squared. So that's just 100 minus 10t plus 4t squared. So if we plug 1 in for this, it's going to be 90 plus 4, that's square root of 94, that's positive. So then we need to check the derivative of this to see if the derivative of this is the same sign. If it's the same sign, then it's increasing. If it's the opposite sign, it's decreasing. So went ahead and did the chain rule. So I've got the 1/2 in the front. Sorry, this is not, I didn't space this out very well. It's negative 1/2 times negative 10 plus 8t. So I'm going to go ahead and write what I've got. I've got negative 10 plus 8t on the top. On the bottom, I have 2 times the square root of this whole thing. And I already know that this whole thing on the bottom was 94, because I already did the math for that, when you plug in 1. So if I plug 1 in on the top, that's going to be negative 10 plus 8. So that's negative 2 divided by 2 times the square root of 94. These two are opposite signs. So that means it's slowing down.